Alright guys, welcome back. Today we're going to be doing complex numbers in Algebra 2, and we're going to be doing the section called what are the complex numbers. So we're going to watch the video on Intro to Complex Numbers, and then we'll do the article.
Most of your mathematical
Yep.
lives, you've been studying real numbers. Real numbers include things like 0 and 1 and 0.3 repeating and pi and e, and I could keep listing real numbers. These are the numbers that you're kind of familiar with. And then we explored something interesting. We explored the notion of, well, what if there was a number that if I squared it, I would get the negative 1? And we'd find that thing, that if we squared it, we got negative 1. We defined that thing as I. And so we defined a whole new class of numbers, which you could really view as multiples of the imaginary unit. So imaginary numbers would be I and negative I and pi times I and e times I. So this might raise another interesting question. What if I combined imaginary and real numbers? What if I had numbers that were essentially sums or differences of real and imaginary numbers? For example, let's say that I had the number, let's say I call it z, and z tends to be the most used variable when we're talking about what I'm about to talk about, complex numbers. Let's say that z is equal to the real number 5 plus the imaginary number 3 times I. So this thing right over here, we have a real number plus an imaginary number. You might be tempted to add these two things, but you can't. It won't make any sense. These are kind of going in different, well, we'll think about it visually in a second, but you can't simplify this anymore. You can't add this real number to this imaginary number. A number like this, let me make it clear, that's real, and this is imaginary. A number like this, we call a complex number. A complex number. It has a real part and an imaginary part. And sometimes you'll see notation like this, where someone will say, well, what's the real part? What's the real part of our complex number z? Well, that would be the 5 right over there. And then they might say, well, what's the imaginary part? What's the imaginary part of our complex number z? And then they'll tell, and then typically the way that this function is defined, they really want to know, well, what multiple of I is this imaginary part right over here? And in this case, it is going to be 3. And we can visualize this. We can visualize this in 2 dimensions. Instead of having the traditional 2-dimensional Cartesian plane with real numbers on the horizontal and the vertical axis, what we do to plot complex numbers is on the vertical axis, we plot the imaginary part. So that's the imaginary part. And on the horizontal axis, we plot the real part. We plot the real part, just like that. We plot the real part. So for example, z right over here, which is 5 plus 3i, the real part is 5. So we would go 1, 2, 3, 4, 5. That's 5 right over there. The imaginary part is 3. 1, 2, 3. And so on the complex plane, we would visualize that number right over here. This right over here is how we would visualize z on the complex plane. It's 5, positive 5 in the real direction, positive 3 in the imaginary direction. We could plot other complex numbers. Let's say we had the complex number a, which is equal to, let's say it's negative 2 plus I. Where would I plot that? Well, the real part is negative 2, and the imaginary part is going to be, you can imagine this is plus 1i, so we go 1 up, it's going to be right over there. So that right over there is our complex number. Our complex number a would be at that point of the complex, let me write that point of the complex plane. And let me just do one more. Let's say you had the complex number b, which is going to be, let's say it's 4 minus 3i. Where would we plot that? Well, 1, 2, 3, 4, and then let's see, minus 1, 2, 3, or negative 3 gets us right over there. So that right over there would be the complex number b.
Alright, that was quick. Let's move on to the article. So in the real number system, there's no solution for the equation x squared equals negative 1. In this lesson, we study a new number system in which the equation does have a solution. So it's I. We learned about this one in the previous episode, but I'll go over it again. The backbone of this new number system is the number I. I equals the square root of negative 1. By taking multiples for this imaginary unit, we can create infinitely more new numbers. For example, 3i, I square root of 5, and negative 12i are all examples of pure imaginary numbers, or numbers in the form of bi, where b is a non-zero real number and I is I. So adding real numbers to these pure imaginary numbers creates even more numbers like 2 plus 7i and 3 minus square root of 2i. While these are not pure imaginary numbers, they are not real numbers either. Instead, they belong to a set of numbers called the complex numbers. Defining a complex number. A complex number is any number that can be written as a plus bi, where I is the imaginary unit and a and b are both real numbers. So this right here is the real part right here, and then this is the imaginary part right here. The real part of the number, or a, is the real number that is being added to the pure imaginary number. The imaginary part of the number, or b, is the real number coefficient of the pure imaginary number. The table below shows the example of complex numbers with the real and imaginary parts identified. Some people find it easier to identify the real and imaginary parts of the number if the number is written in standard form. Here's the complex number, 7i minus 2. Standard form is negative 2 plus 7i. The real part is negative 2, this one in front. And the imaginary part is 7i. Whichever part has the I is imaginary. So this would be 4 minus 3i equals 4. In standard form is 4 plus negative 3i. The real part is 4. The imaginary is negative 3. So on and so forth. 9i is 0 plus 9i. Negative 2 is negative 2 plus 0i. So what is the real part of 13.2i plus 1? Well, we could change it into standard form, so we just put the 1 in front, so it'd be 1 plus 13.2i. And we know the part that's in front, or that doesn't have the I on it, is the answer. There we go. Now, what's the imaginary part of 21 minus 14i? Well, to put this in standard form, we'd make this a plus sign and add a negative sign in front of the 14. That way, we'd know that negative 14 is the imaginary number because it's the one connected to the I, so it'd be negative 14. What is the real part of 17i? Well, if you see up here, 9i, you just add a 0 in front, 0 plus 9i. So this would be 0 plus 17i. And since 0 is the part without the I, it's the real part of the number. Alright, classifying complex numbers. You may have noticed that 9i and negative 2 were given above as examples of complex numbers, even though they can be classified as pure imaginary numbers and real, respectively. This is pure imaginary, this is real. Let's take a closer look at this to try and understand how number sets fit together. 9i is a pure imaginary number, yet we can also express this number as 0 plus 9i. So 9i is both a pure imaginary number and a complex number. In fact, every pure imaginary number is also a complex number. Similarly, negative 2 is a real number, yet we can express negative 2 as negative 2 plus 0i. So negative 2 is both a real number and a complex number. Also, every real number is also a complex number. So here's a little chart. Everything inside of the orange box is a complex number. That's all of these. Negative 3 minus square root of 3i, 4 plus 2i. Everything inside of this whole square, even inside the purple, even inside the blue, this is all complex numbers. And then everything inside the purple is only real numbers, but they're also complex because they're also inside, and pure imaginary numbers is in the blue. So in general, any non-zero complex number, a plus bi, will also be a pure imaginary number if a equals 0, and a real number if b equals 0. So if this is 0 over here, this whole thing is 0, then it's also a real number. And if this a is 0, then it's also an imaginary number. So the diagram shows how the real, pure, imaginary, and complex number sets fit together. Examples of numbers of each type are given. So that's just this diagram up here. Which of the following is the following statement true or false? Any complex number is either real or pure imaginary. Well, these are all complex numbers, and these are also complex numbers. But any complex number, which means also, another way you could say is every complex number is either real numbers or pure imaginary. Well, these are both, this is real numbers, these are pure imaginary, which means there shouldn't be any other numbers anywhere in this box, but there are numbers that are just complex numbers, and they're not real numbers or pure imaginary. So this is a false statement. In the table below, we have classified several numbers as real, pure imaginary, and or complex. Real, pure imaginary, and or complex. And notice that in the table, all the numbers listed are complex numbers. This is true in general. All numbers. So, see 7 plus 8i. It's not a real number, but it is a complex number because it has both parts. This one is a real number, but it's not a pure imaginary number because b equals 0. This right here equals 0. But it is a complex number. It's a similar thing. B equals 0, so it's a real number, but it's also a complex number. We know that this is a pure imaginary because it has the I, but it doesn't have another part. A equals 0, so it's complex as well, though. And 0 plus 100i, that is a pure imaginary because of this. And then it is also complex. What type of number is negative 2 plus 3i? Well, we can see up here that all of these that are just 1, that are, well, all of them are complex, but they're all the ones that are real or pure imaginary are all one part, because the other part would equal 0. And we know that this has both parts, so we know that this is a complex number. What type of number is 10.2? Well, we know it's a real number because it's a normal counting number. And we know it's a not a pure imaginary number because there's no I. But all real numbers are also complex numbers, so we know that. What type of number is negative 17i? Well, we know it's a pure imaginary because it's just a number. It's a real non-zero number in front of I. We know it's not a real number because it's pure imaginary, and all pure imaginary numbers are complex. Why are these numbers so important? So why do we study complex numbers anyway? Believe it or not, complex numbers have many applications. Electrical engineering and quantum mechanics are just a couple. From a purely mathematical standpoint, one cool thing about complex numbers is it allows us to solve any polynomial equation. For example, polynomial equation x squared minus 2x plus 5 equals 0 does not have any real number solutions, nor any pure imaginary number solutions. However, it does have two complex number solutions, and these are 1 plus 2i and 1 minus 2i. As we continue our study of mathematics, we will learn more about these numbers and where they are used. Oh, that's not what we want.
Dot.
So we're going to do a couple practice problems here. So what is the real part? Well, we know the real part since this is written in standard form. We know the real part is the part in front and the part that doesn't have I, so negative 302. And what is the imaginary part? Well, that's the part that's connected to I. That's 19.3. But I did forget a negative sign. Oh, no, I didn't. So what are the real and imaginary parts of z? Well, we know that 20 is connected to the I, so we know that 20 is the imaginary, and 26 is not, so that is the real. So 26 is the real, 20 is the imaginary. 26 is the real, 20 is the imaginary, and it's not connected to the I when you write an imaginary number, an imaginary part of a complex number. Now, what are the real and imaginary numbers of these? So, well, we know that negative 19 right here is the real part, negative 19. And we know that because it's not connected to the I. And we know that negative 24 is the imaginary part because it is connected to the I. It is multiplied by the I should say. Alright. Now, what is the real part of z? Well, the real part of z here is the part that's not multiplied by the I, and that would be the 14. And what is the imaginary part of z? Well, that would be the part that's connected to the I, and that's negative 19. Negative 19. So we'll check, and we'll show summary. Got them all right. All right, practice. We have a second. Classifying complex numbers. Well, what type of number is 12.5 plus 27i? Well, we know it's not a real number because it has an I in it, and we know it's not a pure imaginary number because it has a real number that isn't multiplied by I. So we know it's not pure imaginary, so it must be complex. Also, this one's similar It's not a real number because it's got an I. It's not a pure imaginary because this isn't multiplied by I. And we know it's complex because it's got both parts. It's got both a real and imaginary part that are being added or subtracted. In that case, they were being subtracted. What type of number is 3 minus 719i? Well, it's not a real number because it has this part. And it's not an imaginary number because it has this part. So we know that once again it is a complex number. Now, what type of number is negative 240.1? Well, we know it's a real number because there's no I, and it's a normal counting number. We know it's not a pure imaginary number because there is no I. And we know it's not a complex... Oh, well, actually, we know it is a complex number because all real numbers and all pure imaginary numbers are complex numbers. So that's all for the stream today, guys. That was what are the complex numbers. Tomorrow we're going to be doing the complex plane. Thank you guys all for watching, and bye.